Bismillahirrahmanirrahim. This is your chemistry teacher. Today we will discuss about the chapter solids. This is the chapter number 6 from your first year chemistry. Today we are learn about the introduction of solids, the KMT postulates. KMT stands for kinetic molecular theory postulates for solids, properties of solids, then types of solid, then properties of crystalline solid. Solid state chemistry. This is the structure of solids. Solid particles are very close to each other. Here, general characteristics of solid state. Number 1 is solids have definite mass, volume and shape. Number 2 is intermolecular distances are short. Distance between the molecules of solids particles are very short. Number 3, intermolecular forces are strong. The force of attraction between particles of a solid are very strong. Number 4, their constituent particles, atoms, molecules or ions have fixed positions and can only oscillate about their mean positions. Means the solid particles have only vibrational motion at their mean positions. Number 5, they are incompressible and rigid. The solid particles are incompressible and rigid. These are the general characteristics of solid state. The most common question is why solids have definite shape? Why solids have definite shape? Here are the examples of solid particles. The answer of this question is that in the solid state, a substance has definite shape due to the maximum intermolecular forces existing between the molecules. The molecules of a solid are closely packed together, so therefore have a maximum intermolecular forces. It is little affected by changes in temperature and pressure. That's why the solids have definite shape. The concept of interionic, intermolecular and interatomic forces are that the forces exist between the ions, atoms or molecules which keep them together in a crystalline solid. In a crystalline solid, there are types of forces which combines the particles together. This gives a definite shape. Due to these forces, the solid particles have a definite shape, rigidity and mechanical strength to the solid. Such forces are called interionic, intermolecular and interatomic forces. These forces are of different types in different solids. Have you got my point, students? Our next topic is, the most important topic is postulates of KMT of solids. KMT stands for kinetic molecular theory of solids. According to KMT of solids, the number 1 is attractive forces between the particles of a solid. The attractive forces among the molecules are maximum due to the closest packing of the molecules. The particles of a molecule are closely packed together, therefore the attractive forces among the molecules are maximum. Number 2 point is rigidity. Number 2 is rigidity. The molecules in solids are closely packed again and again. The same thing is that the molecules in solids are closely packed. Therefore, their movement is restricted, so the particles have restrict movement. As a result, they are rigid in nature, so that's why they are rigid in nature. The molecules cannot move due to the maximum attractive forces between them. However, molecules vibrate about their mean positions. That is, the solid particles have only vibrational motion. The point number 3 is high density. The molecules of a crystalline solid are closely packed. The main thing, the basic thing is the molecules of a crystalline solids are closely packed. As a result, the molecules of a solid occupy minimum volume. So the particles of a solids have minimum volume, as density is inversely proportional to the volume. Therefore, high density will be observed, the maximum volume existing between the molecules. High density will be observed due to the maximum volume existing between the molecules. The number 4 point of our KMT of solid is collision. As there is no translational movement of particles in a solid, because solid particles have vibrational motion. Therefore, there are no collisions among the molecules. Point number 5 is kinetic energy. There is a negligible translational and rotational kinetic energy in solid molecules because the solid particles are very close together. However, they can be vibrate about their mean position. So, the molecules of a solid possess only vibrational kinetic energy. The point number 6 is geometric shape. The crystalline solids have definite distinctive geometrical shape. It is due to the definite and orderly arrangement of atoms, ions or molecules in three-dimensional shape. The solids have particular definite shape due to the close packed structures and a strong molecular force of attraction between the particles of a solid. So there are 6 postulates of kinetic molecular theory of solids. Are you understands my point? Have you got the topic of postulates of KMT of solids? Our next topic is properties of solids. Properties of solid crystals. Here is the explanation of our properties of solid. The number 1 is diffusion. The diffusion depends upon the velocity of molecules. The diffusion depends upon the velocity of molecules. As a movement of molecules is very slow in solid because the solid particles have strong force of attraction. Therefore, the diffusion will be minimum. That's why the solids compound, the solid crystals have the minimum diffusion ability. Number 2 point property of a solid are compression, that is effect of pressure. There is practically no effect of pressure on solids. Underline or understand the concept of no effect of pressure on solids as the molecules are very closely packed together. Therefore, its compressibility factor is the effect of pressure on solids is expressed in terms of compressibility. This is defined as the decrease in volume per unit volume. The decrease in volume per unit volume. when the pressure is increased by 1 atmosphere. It is called the compressibility factor, and the solids have no effect of pressure on it. The next is expansion. The solids expand when heated, that is, their volume increases. When the solid particles are heated, the particles expand and the volume increases. This is because the increase of a temperature decreases the intermolecular attractive forces. As a result, the volume increases. When the temperature increases, the force of attraction between the particles of a solid get low. That's why the solid particles expands. When a solid is heated, its geometric shape changes until a certain temperature. It changes into the liquid form. The temperature at which a solid changes into the liquid form is called melting point of the solid. When solid start to change its state from solid to liquid, that point is called the melting point of the solid. Number 4 is motion of molecules. Motion of molecules. There is no translational and rotational motion due to the presence of strong intermolecular forces in the crystalline solid, as the molecules are already closely packed together. However, the molecules can vibrate about their mean position. The main thing according to solids are the solid particles have vibrational motion. Number 5 is intermolecular forces. In solids, the intermolecular forces are maximum between the particles. These are held together in a fixed position by strong attractive forces. They can vibrate only about their fixed position. Due to intermolecular forces, the molecules of solids are closely packed. Again the same thing. Again the same concept, that the solid particles have the maximum force of attraction because they have a very low distance between the particles of a solid. The sixth property is kinetic energy. According to the kinetic molecular theory, the attractive forces between the solid particles are maximum. This is due to the minimum distance between them. So that's why they have a minimum distance between the particles of a solid. Therefore, molecules do not possess translational and vibrational kinetic energies. However, they can vibrate about their mean position. They can vibrate about their mean positions. So they possess vibrational kinetic energies. Now, our next topic is types of solids. Our next topic is types of solids. There are three main types of solids. Number 1 is crystalline solid. Number 2 is amorphous solid, and the number 3 is polymers. Now in our advanced era, the polymers have a large value in a polymeric chemistry. Amorphous solids in detail. What is the amorphous solids? Solids which have their atoms arranged in a completely irregular structure are called amorphous. Amorphous means without shape. It doesn't have a particular shape. The example of amorphous solid is glass. An orderly arrangement of beads shown on the left illustrates the arrangement of atoms in a crystalline solid. Here, this is the crystalline solids. The arrangement of beads on the right would be the representative of an amorphous solid. It is randomly arranged. Here is the detail about the amorphous solids. The solids which have no definite geometric shape are called amorphous solids. For example, glass, rubber, and dust are the examples of amorphous solids. Here is the arrangement of crystalline solids and amorphous solids. Crystalline solids are particularly arranged and the amorphous solids particles are randomly arranged. Amorphous solids which do not have any definite geometrical shape are called amorphous solids. Properties of amorphous solids are considered to be supercooled liquids in which the force of attraction holding the molecules together is so great that the substance is rigid and there is no regular of structure. They do not have a regular pattern structure. Amorphous solids do not have sharp melting points. They gradually soften on heating. Absence of a sharp melting point suggests the absence of a long range order of amorphous solids. Amorphous solids, these are the arrangement of particles of amorphous solids. These are the example of amorphous solids, the cotton candy. The next type of solid is crystalline solid. The solid which have a definite, regular and three-dimensional geometric shape are called crystalline solid. Some crystalline solids have certain molecules of water that is called as water of crystallization. Here is the example of crystalline solids. Copper sulfate with 5 molecules of water. Sodium sulfate with 10 molecules of water. Crystalline solid. The atoms in a crystalline solids are arranged in a regular, repetitive manner, forming a 3D lattice structure. These are called the crystalline solid. Here is the difference between amorphous and crystalline solid. So you easily understand the concept of crystalline solids and amorphous solids. Crystalline solids, they have a definite shape and a geometrical form. They do not have a definite geometrical shape. They have a sharp definite melting point because it have a three-dimensional structure. They melt over a wide range of temperatures. That's why they don't have a sharp shape. They are rigid and incompressible. They too are usually rigid and cannot be compressed to any appreciable extent. However, graphite is soft because of its unusual structure, because graphite has a layers structure. Next is they give a clean cleavage, that is break into pieces with plain surfaces. They give irregular cleavage. They have a definite heat of fusion. They don't have a definite heat of fusion. Anisotropic, that is their mechanical properties and electrical properties depend upon the direction along which they are measured. Isotropic, that is they have a similar physical properties in all directions because the constituents are arranged in random manner. It don't have a three-dimensional structure, so their properties are similar, but they possess a three-dimensional structure, so their properties are different for different plane of structure. So there is the detailed concept of crystalline solids and amorphous solids. Our next topic is properties of crystalline solids. Here, the number 1 property is geometrical shape of a crystalline solids. Geometrical shapes. Crystalline solids possess a definite geometrical structure. That is, NaCl, sodium chloride, is cubic in nature. Amorphous solids do not have definite geometric structure such as a glass. Here is the example of sodium chloride, a structure of sodium chloride. The crystals of every crystalline solid have a definite geometrical shape due to definite and orderly arrangement in three-dimensional shape. That is crystalline solid and that is amorphous solid. Almost all the crystalline solids have a definite, distinctive geometrical shape because the molecules have fixed positions. Therefore, they cannot move appreciably. Moreover, the solids have orderly arrangement of atoms, ions or molecules in three-dimensional space. For example, sodium chloride is cubic in nature. Our next property of crystalline solid is melting point. Pure crystalline solids have sharp melting point. When a solid is heated, the atom, ions or molecules are present in a solid start vibrating at higher frequency and transfer their kinetic energy throughout the solid. At a fretting point, their vibrational energies become so much that they leave their fixed position simultaneously and become a liquid. That is the concept behind when solid change its states from solid to liquid. There are many crystalline solids which do not change directly to liquid state, and also there are many crystalline solids which decompose before going into the liquid state. The crystalline solids directly change into liquid state do so at a definite temperature. For example, the melting point of such crystalline solid is definite. Number 3 point is cleavage plane. Cleavage plane. What is the cleavage plane? What is the concept of cleavage? Here is the definition. The breaking up of larger crystals into smaller ones with identical size and shape is called cleavage. The plane which contains the direction of a cleavage is called the cleavage plane. The two different terms are used. One is cleavage and second one is cleavage plane. A crystalline solid contains atoms, ions or molecules closely packed to each other. When some external pressure is applied to it, it changes into small crystals of the same size and shape as that of the original one. Nickel sulfate with 6 molecules of water crystal can be cleavage easily provided cleavage is parallel to the surfaces. This is called cleavage planes. The next point property of crystal is habit of a crystal. What is the definition? What is the concept of habit of a crystals? The shape of crystals in which it usually grows is called the habit of a crystal. Cubic crystals of sodium chloride are obtained from its aqueous solution. If the conditions are changed, the shape of crystals also changes. If 10% urea is present in aqueous solution of sodium chloride, octahedral crystals of sodium chlorides are obtained. Conditions would be changed, the shape of crystals would be changed. Crystal habit is the ideal shape of a crystal faces. Ideal faces require the ideal growth conditions. Many destructive terms are used to characterize habits. Here are the different shapes of crystals: cubic, octahedra, blades, hexagonal prism, rhombohedral, tetragonal prisms, compound forms. Next property is crystal growth. What is crystal growth? The crystal growth takes place when the heated solution of a substance is allowed to cool in a slow manner. When you slowly cool the heated solution of a substance, the outer appearance or shape of a crystal depends on how it is prepared under what conditions. A crystal with cubic structure may develop into a cube, a flat plate, or a long needle-like structure under different conditions. The size of a crystal is controlled by its rate of growth. A slowly growing crystal has a large size. Here is the crystal growth of a crystalline solid. Our next and most important property is anisotropy. What is the concept of anisotropy? In exams you have a question, you write a short note on anisotropy. So it is definition, explanation and examples. So the definition of anisotropy is a substance which shows different intensity of properties in different directions, in three-dimensional directions, is called anisotropy, and this property is anisotropy. This is the explanation. A crystalline substance is built up of small units, all having the same geometrical form, but although a crystal is homogeneous, it possesses different properties in different directions. It is because the crystal has different arrangement in different directions. For example, graphite exists in the form of layers, so it is a conductor in one direction parallel to the layers, but insulator across the layers. Refractive index, coefficient of thermal expansion, electrical and thermal conductivities give different intensity of properties in different conditions. Mica can be cut parallel to the layers but difficult to cut in some other plane. This is the concept of anisotropy. Next point is symmetry. Symmetry. There are certain crystalline substances which, after rotation to certain angles, give similar edges, corners or faces at different distances in different directions. The rotational operation which brings the crystals into its original appearance is called symmetry of elements. It is called the symmetry of elements. For example, if a regular cube structure is rotated about its axis at an angle of 90 degrees, the identical face is obtained. On rotating to its 180 degree, a second identical face, and at 360 degree, 4 identical faces are observed. An axis containing 4 identical faces is called four-fold axis of rotation. The process through which the crystal was brought back to its identical position is called symmetry operation. The next property is isomorphism. Isomorphism is the basic concept. What is isomorphism? Substances are said to be isomorphous which are similar in crystalline form and in chemical properties can be represented by similar formula. There are certain substances which are similar in shape. Different crystalline substances have the same crystalline shapes are called isomers, and this phenomena is called isomorphism. That is, the two different compounds have a similar structure. Two different compounds have a same structure are called isomorphism. Zinc sulfate and nickel sulfate are isomorphism because both have the same crystalline shape, that is orthorhombic. Ag2SO4 means silver sulfate and sodium sulfate are hexagonal. Atomic ratio are same, 2 for silver and sodium, 1 for sulfur, 1 for sulfur, and 4 for oxygen and 4 for oxygen atoms. So atomic ratio is same. That's why they have a same structure, that is hexagonal, but the two different compounds are. The next is calcium carbonate and sodium nitrate are rhombohedral. The atomic ratio are same, 1 for calcium sodium, 1 for carbon and nitrogen, and 3 for oxygen. Examples of isomorphism here: sodium chloride, sodium bromide, and magnesium oxide. Both have the same atomic ratio, 1:1, 1:1, 1:1. So have a cubic crystal. Sodium nitrate, calcium carbonate have rhombohedral crystals. Isomorphs usually have the same atomic ratio. Have you got the point about isomorphism? The next is polymorphism. It is the opposite of isomorphism. When a substance exists in more than one crystalline form, the different forms are designated as polymorphs, and the phenomena is polymorphism. That is, silver nitrate have two different geometrical structures. It is exists in the two different geometrical structures, rhombohedral and orthorhombic. This concept is called polymorphism. So students, have you got all these points, all these concepts? Thank you for your attention. If you feel any query, you feel free to ask questions. I will reply you the every answer for your questions. Thank you very much.